I've been talking about a tool in the last couple of weeks that I call the universal movie. And one fellow says, why do we need the universal movie? And so we need to start there before we can move on to location, because these people are still need to go through kindergarten before they get to first grade, let alone to college. These people want to jump to college and say, let's do physics, Bill. No, we can't, because you still don't understand the language. Okay, so you need to understand the language before we can move on to something a little higher than what your brain can tolerate right now. Okay, so this fellow says the following. He says, what makes the universe anything like a movie that you can pause to get a frame? I've never seen a frame before. Can you please explain the concept and why you need this concept for physics? Is the universe an object or a relationship between two or more objects, also known as concept, or is it both? Please help me understand rational science. Are these people for real? Okay, so let's go with that second question first. Let's find out what a universe is, why the universe is a concept, and why you cannot treat universe, the word universe, as a noun in physics. Universe is not a noun, and no concept is a noun, okay, in physics. In physics, the only things that can serve as nouns are things, are objects, are, those things, that which has shape, or those which have shape. Those are the only ones that qualify as nouns. You cannot use verbs as nouns in physics, okay? And so here we have it, universe. What is universe? Universe is space and matter, okay? And we treat space as a physical object. We treat matter as a physical object temporarily, only for the purposes of defining universe. So we have a relation between two objects. We treat space as an object and matter as an object. We have this relation. We need both of them to define the word universe. So some people say, relativists, that they put an article in front of the word universe. The universe is expanding. Totally irrational statement. You cannot say that the universe is expanding. You can say that space is expanding. If you treat space as a physical object in your theory, you're going to assume that space is a physical object, and you say space is expanding. Okay, we can all understand that, like a balloon or maybe a bunch of water that's expanding or whatever. Okay, you can do that. That's your theory, fine, that's what you're going to present, that's fine. So you can say space is expanding. You can also say that matter is not expanding. Matter is like a hand grenade. It's exploding, and all the debris is growing apart from each other, every bit from ground zero. That's not expanding, not in the sense of a balloon expanding. Okay, you can say it's exploding, maybe. Okay, maybe that's a correct word, but for sure you cannot say the universe. Okay, because universe is a concept. Concepts don't expand. Does love expand? You can say love expands. What does that mean in physics? It has no relation to physics whatsoever to say that a concept expands. Okay, so it's irrational to say that the universe expands. Either space expands, which is really what they're referring to, because they're saying that since the Big Bang, it's space which is expanding. Space, time. This concept, okay, fine, we'll treat it as a physical object for the instant purposes. We can say that space-time, assuming it's some kind of balloon, it's expanding. Okay, we understand that. It's a balloon that's expanding. But not the universe, because the universe includes the particles, in other words, every atom, meaning every galaxy, every star, everything out there, everything, which is not space. So you cannot say that this relation between space and matter are both expanding, because what you have is a relation that is expanding. So it's irrational to say that the universe is expanding, which is what relativists say. They use those terms constantly. Okay, here we have the second part, or the first part of this fellow's query. Okay, why do we need it? We need the universal movie because we need to establish the difference between static concepts and dynamic concepts. Okay, static concepts are those that can be found, that can be imagined or created or invented for a single frame of the universal film. In that single frame, every object in the universe, every atom in the universe has a certain distance from every other atom. Nothing is moving. Not even an electron moves in that frame of the universal film. But when you have those bottom ones, like motion, plasma, etc., ether, field, and so on, you need at least two frames of the movie. Okay, you need more than one frame. And so the issue that we've been dealing with is those upper ones. The object, you can see any object in there is just a single picture of one object. Could be an atom, could be an electron, could be a galaxy. It doesn't matter. You can have whatever object you want in there. Distance, the separation between all objects. And today we're going to be looking at location. Okay, so those are static concepts. But you cannot use any of the dynamic concepts because those involve at least two frames of the universal movie. You need to have two, what we're going to call today, locations in order to have any kind of motion. Okay, so the universal movie allows us to look at a single frame where nothing is moving, and that allows us to identify first the objects and all the static concepts that we're going to be defining, such as distance and today location. Okay, so one fellow says, I guess you can see how these people are lost, why we need the universal movie. It says distance, the magnitude of displacement between two positions. The distance between two positions is not the same as the distance traveled between them. But he talked about displacement between two positions, but he says displacement is not distance traveled. Well, what is displacement? I thought displacement was distance traveled. What's the difference? Distance traveled is the total length. Now he's talking about length of the path traveled between two positions. So this fellow seems to go around in circles. He says that, the magnitude of displacement between two positions. Okay, and then positions is already a distance traveled, and that's also the path traveled, and he says that's the same thing as the length. So the question is, what is he talking about? And he says distance traveled is not a vector. In fact, it is, because vector, well, not the vector of physics, but the vector of mathematics, mathematical physics, the vector is a number line, and number lines are all distance traveled, all of them. Not a single number line is anything other than a distance traveled. And distance traveled defines how much path an object has covered. Yeah, how much path, meaning how many meters, how many feet. So you're measuring tiles, you're unrolling the measuring tape, so many meters, so many tiles, so many inches, so many whatevers. And yeah, that's what it is. And then he says in a period of time, meaning, again, we're introducing more dynamic concepts. Time is a dynamic concept. So this fellow is just going around in circles. He doesn't realize that distance, just separation, has nothing to do with anything that he defined there. Okay? But that's him. Here's another fellow, and he says the following. He says, the universal movie is a concept that necessarily moves. Necessarily moves by defining existence as moving. I have no idea what's going through these people's minds. Whereas we have a single frame, nothing is moving within a frame, and existence is defined as a static concept, meaning only within what happens, or happens with quotations, right? What is there in a single frame. Okay, so we have physical and presence. One is object, the other one is location. Those are two static concepts. They all fit in a single frame. You don't need two frames for that. Existence has nothing related to motion. There is no provision for motion in the word exist, no provision for time either. Okay, so I have no idea what's going through this fellow's mind. Okay, another fellow, he says, he tries to define motion. He says the following, he says, motion is the property of what gets from point A to B over time. So to define motion, he said he's going to use time. Turns out that you cannot define time without motion. And memory for that matter, but that's a second issue. But you cannot define time without motion, so he's going to use time to define motion. What's the problem with all these people? The problem is very simple. Well, there's a couple problems. Let's go through the list of problems, but here you will see why. Okay? They never learned how to define words scientifically. In fact, very few people, if any, out there have. Not a single dictionary out there has learned to define the key words of physics in a scientific manner. And that's why in mathematical physics, there is not a single word that is scientifically defined. Okay? They dismiss definitions as semantics. When you bring up arguments saying, well, what did you mean by exist? And what did you mean by this and by that? They say, oh, you're raising semantic arguments. I didn't come here to do grammar. I didn't come here to do English. That's for English majors, librarians. I came here to do physics. You know, like the Chinese fellow, and he comes to, Texas. And he asked the Texan, he said, why do all people say y'all? Y'all this, y'all that. Well, let me explain to you what y'all means. Let me define it for you. No, I didn't come here to learn grammar. I just want to know why everybody calls everybody y'all. I came here to look at customs, at behaviors, and people are saying y'all all the time. Yeah, but let me define it for you so that you understand why people say y'all. I said, no, but I don't want to understand that. I didn't come here to do grammar. And these people are the same. So they say, what they do, they copy-paste definitions from the dictionary, ancient definitions. They look at etymology, where does this word come from? How did our ancestors create this word? Why did they create it? What is the origin of this word? It's got nothing to do with anything, because if it was misdefined from the start, then we have no use for that word, especially those key words that we're going to use in science. If it's a common word that has no importance, then we can use the common word and say, okay, where did it come from? That's fine, that's history. But if we're going to use a word that is key in physics, like object, like exist, like distance, like location, hopefully we will not use the dictionary. Any word that was defined by our ancestors because they had no clue what they were defining. That's the issue. So we cannot say, well, what is the etymology of this word? We don't care. If it's broken, we're going to fix it. Okay? And we don't care what everybody on earth votes for. Okay? So we don't use tradition, we don't use democracy, we don't use authority. None of those arguments are valid. If it's broken, we fix it. We redefine it in such a way that we can use it consistently, meaning scientifically. Okay? But above all, never learn that you must define static concepts before you define dynamic concepts. Not one of these bozos of the past, none of these famous scientists, famous physicists, famous philosophers, not one of them ever figured it out. You need to define static concepts before you define dynamic concepts, and that's the role of the universal movie. You must define static concepts before you define dynamic ones. Okay, so this is where the problem begins. And so we have a word that one of these fellows used, position. And in mathematics, they confuse position, or a lot of people say, they never define location. They use the word position. And they don't realize position, as defined by the mathematicians, is an ordered pair at its simplest form, right? An ordered pair is not a point, is not a location, not a position, which is a static concept. It's quite the opposite. An ordered pair gives you a way to get to there, to that point, to that location. Okay, and here you see it. Okay, here's the definition. One of the definitions you find out there, but they're all the same. Okay, an ordered pair is used to represent the position of a point. And there you see an example. Okay, 2, 4. Okay, so if you go on the x-axis in one direction and the y-axis in the other, well, then you end up at 2, 4. So is position 2, 4? Where that dot is? No, position is how to get there, because it's represented by an ordered pair. Okay, so this is a position. Okay, here's graphically so that you can understand it. Let me get rid of this one here. Okay, here you see what position is. Location, physics, it's a qualitative concept. Where's the treasure chest? That's what we want to know. And it's a static concept, and all we have is a separation from, in this case, the treasure chest to every object in the universe. Just a separation. What is position according to math? Well, it's how to get there. It's the instructions, how many steps you got to take, to the right, and how many north in order to get to the treasure chest. That's what position is. For the purposes of physics, position is an irrelevant word, so we don't need it at all, because position is the object itself. It's the volume, you could say, occupied by the object, if space were an ocean, so to speak. So if you have a fish inside the ocean, position is, if you took the fish out, whatever he leaves behind as the volume, that's position. It's an exact site occupied by an object. That's position. Therefore, it's an irrelevant notion. We don't need position at all, unless you want to consider it a synonym of location. But for that, we have location. And location is a qualitative concept that just says, look, it's all these separations from every object in the universe. Mother Nature doesn't use measuring tapes. Okay? She doesn't know what a meter is, what a foot is. She doesn't know a kilometer or whatever, mile. She doesn't use any of those concepts. And she doesn't care about them. All she wants to make sure is this object over here, separated from that object over there. This one's twirling around that one. She does qualitative stuff only. Mother Nature never went to school. She doesn't know math. Okay? She's completely ignorant in math and could care less. She doesn't make relations. She just moves objects around. We need to understand how she does it. That's the purpose of a physicist. You got to tell me how gravity works, how she does that magic trick. For that, we do not need any math. We do not need to know how many meters, how much time, how much distance, how fast it went. We don't need how much it weighs. We don't need any of that. We just need to know or understand how she does that magic trick. Okay? You don't need to know math to understand how a magician did a trick. He cuts the lady in half, or he does something with cards. You want to know how he did the trick. Do you need to take a college course in math to understand how he did the trick? No, he just shows you how he did the trick, if he's nice, and you'll learn how to do the trick. That's how simple it is. That's what we want to do with Mother Nature or Father Universe. We want to know how they do their magic tricks. For that, you need no math whatsoever. So we don't need position. We don't need to know how to unroll the measuring tape for how many meters. We don't need to create standards such as the meter or the kilogram or time, the second. We don't need any of that. We just need to know the mechanism, and that had better be objective. Okay, so here we have location. Okay, what is location? Set of distances. It's just separation. Distance is separation, as we covered the other day. And what we have is separation between, for example, the cube there and the baseball bat, the gun, plant, balloon, frisbee, etc. That's the location of the cube in the universe. Okay, you can take it as far as you want. You can look at a single atom. You can look at the cube from every atom in the universe. You can chop it up wherever you want. You can also look at a system and say, well, like in this case, here you only have a few objects, and say, what's the location of that cube? Well, it's at a separation from the baseball bat, from the gun, from the table, etc. That's the location of that object. It's a qualitative stuff, because you're going to explain a mechanism, how the cube maybe fell to the table, for example. And for that, all I need to know is its location. I don't need to understand how many meters away it's from the table. I don't need to measure anything. Okay. And physics again versus mathematical physics. Okay, and so here it is again. Okay, the reason we need the universal movie is because we need to isolate the static concept from the dynamic concepts. People have a lot of trouble with that because they confuse the ones at the bottom for physical objects. They think plasma is a physical object and they use it as a noun. They say, oh, plasma did this and plasma did that. They also do it with electricity. They say electricity is the cause of gravity. You cannot say that, okay, like the electric universe says. No, you cannot use electricity as a noun and say that electricity causes gravity. You got to identify what the object is, okay? And hopefully it's not electricity anyways, because electricity not only is a process, but it's a one-way process where the beads move from atom to atom, the electron beads. And how you can pull with that, how you can create attraction with that, well, good luck with that one. Anyways, the universal movie gives us all these static concepts that you have at the top, and we separate them, isolate them, distinguish them from the ones at the bottom, which are all dynamic concepts, okay? And location, as you can see, is at the top. It's a static concept. It's the set of distances. Distance being what? Measurement? Meters? Kilometers? Feet? No. It's separation. Qualitative separation. The set of those separations gives us location. And eventually we're going to do something with both distance and location once we understand what those two words mean in physics. Physics, not mathematical physics.